So in this last video, in this last example, we're going to see what happens when there is no consequence relation, right? So when the statement of consequence does not hold. So the procedure is basically the same. So we list the premises. We've got just one premise here, and we negate the conclusion, right? Again, be careful. There are no outermost parentheses, so you should add them, right? Okay. So not S, conditional, not P, and you negate that, right? And now you start to apply the rules, as always. So we've got a conditional, and we've got the negation of a conditional, right? If you see the conditional opens a branch, the negation of a conditional does not open the branch, so we go for this one first. That's the easy option, right? So this is not S and not P, and we are done with this, right? And now we've got to go for this one, right? So this is the main logical sign, right? So we are going for this conditional, not for this one, right? So this rule opens a branch. We've got to negate the antecedent, right? Write the consequent. We've got that in this branch, right? In this branch, we've got S, and we've got the negation of S, right? So this branch closes, right? We don't have to inspect it further, right? Because this branch is always telling us, no way, right? There's no, you won't find an interpretation that way. We continue with this branch. Now we've got the negation of a conditional, right? And that's easy. Antecedent and negation of consequent, right? Okay. And now, what happens? Well, it happens that in this branch is open, right? There is no formula and its negation in this branch. We've got not Q, we've got P, we've got double negation of P, not negation of P, right? Double negation of P. And we've got negation of S, right? So this branch, you can mark it this way. I like to do it this way. You can mark it, that branch is open. Now, the nice thing of the tableau or the trees is that they are so kind that they are going to give us the hint, you know, to construct an interpretation satisfying the initial set of formulas, right? And the recipe is very easy. So you've got to clip the open branch, and for any propositional variable in the branch, right? Sorry, for any propositional variable whatsoever, if that propositional variable is in the branch, the interpretation makes it assigns to that variable 1, right? True. If the negation is in the branch, it assigns the value 0, right? Now, since the branch is open, the interpretation is consistent. It won't find a formula and its negation. So the interpretation won't assign this to the same variable different truth values, right? Which is part of the trick, right? And if the variable is not at all in the branch, you can assign the truth value you like, right? So let's do it for this. We've got negation of Q, right? So our interpretation should assign to Q the value 0, of course. We've got P, right? So the interpretation should assign to P value 1. Not P, of course, will have value 1 as well. And we've got negation of S, so the interpretation will assign to S the value 0, right? Now, the funny thing is that this interpretation makes this true and makes this true. This means that this interpretation makes this true and makes this formula without the negation false, right? So this interpretation is what we can call a countermodel, right? A counterexample, an interpretation showing that there was no logical consequence. This is how trees works, logic works. I'll see you in the next unit.